Hey guys, we always use arrays in C to store multiple values, but today let's know how they work and all ways to declare and initialize them. Let's begin with the definition. What is an array? An array is a collection of elements of the same data type stored in contiguous memory locations. It means instead of storing each element in a different variable, like storing the value of 5 in A or storing the value of 10 in B, like this, instead of storing each element in separate variables, we can use a single variable and we can store all these values 10, 5, 11 and so on. We can store all these values inside this single variable, and this is our array. You will understand how it works by the end of this video. Now let's see how we declare an array. The syntax is like this: data type, and we will give a name to the array with the size. This data type can be of, int, char or float, anything, and this is our variable name. And remember one thing, each array will be having a size. Let me give you some examples. Int num of 5. Here our data type is an integer data type, and it is our array name of size 5. Similarly, we can have like this. Here char is our data type, grade is our array name, and it is size. Cool. Now let's see the different ways to initialize an array. Till now we have seen the declaration of array. These all are array declarations. Now let's see how to initialize an array. We have around 4 methods to initialize an array. Let's start with method 1. This method 1 is direct initialization. It means we can initialize an array directly when we declare it. Before going to remaining initialization methods, let's see how to access and print the values of an array. So we had an array named ARR, and we directly initialized it with the numbers 10, 20, 30, 40 and 50. So the array looks something like this: 10, 20, 30, 40, 50. Each element of the array has an index number. This index number will help us to locate and access each value inside the array. The index number of the first element is 0 and the next element is 1, and it continues like this. By using these index number, we can access all the values of an array. For example, to access the value 10, we should give something like this: array of 0. It means it will locate to the 0th index, and in 0th index we have the number 10, so 10 will be accessed. Okay. Similarly, if we give something like this, array of 3, it means here we are locating to the 3rd index, and in the 3rd index we have 40, so 40 will be printed. Okay. In this way we can access the elements. So to print these accessed elements, we can simply give a printf statement: printf %d and array of 0, and similarly array of 1, 2 and so on. So let's write a code and check it out. Let us take this array, int array of size 5 equal to elements like 10, 20, 30, 40, 50, and then let's try to print the first element. percentage d and array of 0. So let's print it, and we are getting element 10. Similarly, I will print the fourth index element, and I got 50. I need to give a backslash in here to get good view. Yes, we got 10 and 50. Here you need to observe something. We have 5 elements here. Okay, we have 5 elements, but we have index number from 0 to 4. Okay, it means if we have n elements, we can have 0 to n minus 1 indexes. Remember this carefully. Okay, if you have n elements in an array, we will be having n minus 1 indexes, 0 to n minus 1. Here, if you observe, the index of the last element is 4. So what is the value of array of 5? Let's check it out. So if we print something like this, it is getting 0 here. Let's check it out with some other values. Array of 8, we are getting 1. And array of 8, we are getting something like 1. So, and similarly array of 7, we got a value as 32498. So the thing is, these all are garbage values. Okay, these all are garbage values. To know what are these garbage values, you should understand the memory representation of the array, which will be covered in our next part. So here, instead of giving printf statement for each element separately, we can give a single for loop here. I equal to 0 to I less than 5, I plus plus, and printf percentage d, I will give a space array of I. That's it. And I need to declare this I, and I will declare it here. Let's run it. We got some error. Okay, yeah, we got the values 10, 20, 30, 40 and 50. So let's give 10 here. We only have index up to 0 to 4. Cool. But if you want to access the remaining index such as 5, 6, 7, 8, 9, let's see what happens. We are getting some garbage values as I mentioned before. So it is about the accessing and printing of array values. Now let's continue with our remaining methods to initialize an array. The second method of initializing an array is partial initialization. It means having less elements than the size of the array. For suppose our array size is 5, but I'm only initializing 2 elements here, like 10 and 20, and remaining 3 elements I haven't initialized it. So this is partial initialization, and in such cases, what will be the index values? So we know that array of 0 equals to 10 here. Similarly, array of 1 equals to 20 here. But what about array of 2, 3, 4? So what are the values in these three indexes? Let's check it out with the code. I just initialize it with 2 elements, and as my array size is 5, I will just print 5 elements. And see, the remaining elements which I haven't initialized came as zeros. Similarly, if my array size is 10 and if I print up to 10 elements, I will get remaining all as zeros here. By this we can understand one thing. At the time of partial initialization, our compiler will set, remaining elements, as 0. So they are auto initialized. Cool. They are auto initialized. So it is our method 2. Third method is without specifying the size. It means we can directly initialize an array without specifying the size. For example, I am initializing with 1 2 3 4 5, but if you observe, I haven't gave the size here. So what our compiler will do is, we have 5 elements and it will simply automatically assign the size as 5. Let's check it out with the code. I will be getting all these 5 elements. Here I want to introduce this sizeof operator. So instead of manually giving the array size, we can dynamically find the size of an array by using this sizeof operator. The main purpose of the sizeof operator is to determine the size in bytes of a data type or a variable. So to find the size of an array, we have this formula: size of array by size of array of 0. Here this array is our complete array, and here we have 5 elements. Okay, let us do a small math here. For suppose the size of the int is 2 bytes. Cool. The size of the int is 2 bytes, and we have 5 elements in our array. So each element is enough integer type. So total how many bytes our array contain? 10 bytes. 5 2s are 10, right? To understand clearly, I will write it here. We have 5 elements in our array, and each of these are integers. It means each of them will be having 2 bytes. So 2 plus 2 plus 2 plus 2 plus 2, 10 bytes. Cool. And array of 0 means we will be getting 1, and size of 1 will be 2 bytes. Cool. So if we divide these two, 10 by 2, we will be getting the value of 5, which is our size of array. So it is our formula. Cool. And we can use this formula here. In size equals to size of array, size of array of 0, and then I can simply give size here. Let's check it out. And yes, we are getting. And our fourth method is runtime initialization. It means instead of initializing directly at the time of declaration, we will ask user to give inputs at the runtime. Here we will use scanf. So here I will take an array of size 5, for example, and I will initialize a variable I, and then I will ask the user to enter the values, enter 5 elements, and then I will take a for loop I equal to 0 to I less than 5. Here I will use a scanf function to take input ampersand array of I. So at each index I'm asking user to enter an input value, and then after taking all the inputs from the user, I will simply print those values. The elements are, and again I will use a for loop here to print those values. So yeah, that's it. Let me execute this code. And if I run it, It is asking us to enter 5 elements. So I will enter some random elements for 76 and 45, and then yeah, we are getting these elements. So these are methods of initialization of an array. If you guys remember, I mentioned a term in our definition as contiguous memory locations. See? So the thing about these contiguous memory locations and the memory representation of an array will be covered in our next video. And that's it for our video today. Thank you.